So excited to do this one, and it felt like a lot of people throwing a lot of different retrieval. There's a lot of retrieval work going on, different ways of retrieving, different ways of chunking data and overlapping chunks, and all these things you can do. Um, but it felt like a little hard to get an idea of what you should do. Like what should I do, and how do I build and bring maybe some more traditional metrics from search and retrieval to try to measure that. And so what you're going to see here is an attempt at that. I think we've kind of done a pretty good first pass, but the scripts and code will be available for everyone to use and use on their own data and use on their own docs. So it's a pretty good first pass at it. So as I think about observability, which is what Rise is focused on, evaluation is kind of one of the areas around this, and for us, it's around just trusting metrics, trusting the evals that we have, that we're running. I don't think we're opinionated on whose evaluation metrics we use. We do have some base level versions of stuff in our own platform in Phoenix, which is our open source software. But there's Llama Index also has evals as well. So I think we'll spend a lot of time in evals today and kind of how those play into how do you then measure more traditional metrics like say MRR and DCG when you're thinking about retrieval. So as we think about evals, there's at least two ones that are most important to us as we think about the retrieval process. There's one around did I retrieve the right chunks, which is kind of that lower level one here, and there's another one which is did it answer the right question, did I get the right answer for retrieval. So for RAG you're generating an answer. Yeah, and I mean, Jerry, that's what Llama Index does. Do you want to describe a little bit of the process here?
Yeah. I mean, I think for those of you who aren't familiar with this process, basically the idea of RAG is, it's basically two stages, right? First is you need to load in some data into a vector store, and that data, this is independent of actually calling the LLM. You need to format the data in some way in a vector database, and then when you query a RAG system, you first do retrieval from the database. And so you first do top K embedding lookup from the vector database to find the most similar documents to the query embedding. And this is usually just done by embedding the query and then returning some set of relevant results. And that's, I think, what Jason is talking about in the retrieval evals, because that part, a lot of times, right, that part by itself is just independent of the language model call itself. It's just a matter of, are you actually returning the relevant documents given your query? Once you actually return the relevant documents given your query, then you take in those documents and then you put it into the LLM context window and have it try to synthesize a response. And that part is the synthesis portion, right? So when you put the two together, that's the end-to-end evals. Given a question, can you get back an answer? But the intermediate step is basically the retrieve context.
And what we're going to dive into today is a little bit first we'll start with building blocks, which is just how do I make sure the chunk retrieved was good, and then how do we also make sure the Q&A is good, and then how do we use these building blocks for evaluating the entire system. And this is probably an opinion from the Rise team, but this is kind of where we've come to is that that if you're thinking about your evals, you should think about benchmarks, golden data sets. There's a couple we've baked into the library. So every new template we put out, we actually put out a golden data set with it. But then teams, I have tons of customers who just build their own golden data sets. They don't just trust what a team's put out. So golden data sets to test. We also I also really call it precision and recall in F1, like things where I can understand not just an overall average number, but where in the range that the thing is good or bad. You can be very skewed data sets. If you're averaging a number can really pull you off. So we think a lot about precision F1 recall when we think about these metrics. And then also task-based. If you look at OpenAI's evals, they tend to be model-based, where you're varying a template and a task. So I think that's the core idea. And then I do think your eval should be able to run in Llama. You should be able to compare Llama Index and other places where you're running evals. And I think it kind of looks like this. There's some LLM system kind of under test, and there's some eval library that's kind of checking your data, it's flowing through. Maybe you're changing your eval template or your eval LLM based upon what your goals are. And the reason you might change the eval LLM is I've seen a lot of teams are actually running into this issue where GPT-4 is great, but it's slow. And so is GPT 3.5, is 3.5 good enough? Is turbo good enough for the eval I'm running, is a lot of what teams try to figure out. And then, hey, if I can run turbo, I'm about 2.5 times faster than the GPT-4 evals. So this is kind of like the general gist. And then how it works is kind of there's a retrieval template that you might use to validate, like you're comparing a reference text and trying to determine if the reference text contains information to answer the question. So you're trying to ask GPT-4 if the chunk will help answer the question. You're trying to just see if the retrieval is relevant or irrelevant to the question. So on every chunk, you're kind of asking this question. And the reason to do this is like to benchmark your system. You might not do it for every chunk, every run, every time you're in production. You might sample some percent, but the goal is to get some view of like how things are doing, and LLM's a nice way to automate it. Anything else to add on this, Jerry? I know you guys have retrieval evals as well, kind of within Llama Index.
Yeah, I think so. It was actually pretty interesting because I think the one thing that you're doing with retrieval evals here, you're actually just using like a prompt. And so in that case, the retrieval evals is label free in a way. You don't actually need the ground truth context. So like basically, if you see here, the eval template's literally just like, here's a question, here's some context, and then ask you before, like, does the question and context match? So that means that you don't actually need the ground truth retrieved chunk, right? Like a text chunk. And so I think for our retrieval evals, we actually do have a ground truth text chunk. I actually don't know if we have retrieval evals. I might be forgetting. Like, I don't know if we have like the ability for an LLM to evaluate whether a question and context matches.
Got it. The big idea though is just trying to get like, is the chunk relevant? I mean, that's the core idea, that you can then use that information to start to do some analysis of the quality of retrieval. And we'll talk about like the quality of retrievals, like living in my customers' data and living through these, trying to help them evaluate the systems they set up, right? Retrieval performance and understanding retrieval is incredibly important, hard. And I also kind of feel like it's a backbone of the future of AI. Like retrieval is how you feed information into these LLMs for your docs or your information, and trying to get it all to work is kind of the core thing, which we're going to go through. A little bit of like what this means in slightly more detail is you have like a query, you have maybe some chunks you're returning, and then there's that template we were talking about here, where this template's being applied to every single chunk relative to that query. So for chunk 0, you're asking if the query actually answers. The chunk has a chance of answering the question. And there's also a question and answer one, which is like these chunks might generate an answer in the end. And what we found is for private data, and you might have, this is different than like a public question, like what year was Michael Jordan, what years do you win the championships? Like this private questions are typically answered by the chunks returned. Like you're not going to find an answer to technical documentation questions. You're not going to want to rely on GPT-4 to do that. You'd rather rely on your docs you're sending in the window. So typically for question and answer, we're thinking about the question, we're thinking about the chunks returned. So this context typically refers to as all the chunks. You want to kind of fit it in. You want to fit the answer in, and then you're asking like, is the answer correct? And funny enough, like what we've found is, GPT-4 is actually quite good at this. GPT 3.5 is, I would say, slightly less so. But we have metrics, precision, and recall tests on both. And what I find is like it's almost better at analyzing its answers sometimes than it is at actually answering the question. There's something easier about analyzing whether something is correct or not. So we found this is works pretty well. Again, all these are proxy metrics. You're kind of doing it in lieu of labeling, or in addition to labeling in some way. So it gives you some automated proxy metrics. It's not going to take away your labels. It's not going to take away completely the work you're going to do, but it gives you some way of automating views and performance metrics. Cool. So let's start to get to the fun stuff. So first off, I just want to say that from these building blocks, it's pretty important that the building blocks, you believe in them, because like the rest of everything we're going to show is very important that you believe these metrics work. And there's a bunch of data sets and test sets that we've run against these. And I think all the teams who are out there and really, strong engineers, feel free to build your own test sets and prove us right or wrong on this stuff. But the building blocks are key to the next set of things we're talking about. The other piece, Jerry, you go through is the query generation, which is the other piece of data you need if you want to test automate these tests.
Yeah, I think so. I think so far the slides have mostly been about like how do you run these evaluations, and I think one piece here is actually how do you generate the data set. And so I think we have some initial versions here for Llama Index on both like generating some data set for retrieval and also generating like a data set for end-to-end evaluation. But of course, this is like subject to further iteration, and curious to get like community feedback as well. And so the way we think about like generating a data set for retrieval evals is there is ground truth actually, and so that's why it's a little different than what Jason just said. But the advantage of what doing it in a label-free manner, right, without ground truth, is you can just generate questions without actually needing to associate it with a set of chunk, like a chunk beforehand. But if you do want to have ground truth, the way it works is like you take in some document, you parse and chunk it up into a bunch of different text chunks, similar to how a RAG pipeline actually works. You take in a document and split it into a bunch of chunks. And then like for each chunk, you can get GPT-4 or some like good LM to just generate a bunch of questions from each chunk, right? Or if you're creative about it, actually take like 2 chunks and generate questions from that. Then you have like question and chunk pairs, and that becomes your eval pair. So then when you actually, if you want to benchmark retrieval, right, and measure ranking metrics like precision at K, like MR, NDCG, that type of stuff, you can run a question against your retriever, get back a predicted set of chunks, and then see if the ground truth chunk is in that ranked list, and also how far it is in that ranked list, right? And so if like that, therefore you can actually just like take this ground truth data set, and then it just becomes like an information retrieval, like eval problem. So this isn't using LLMs to run retrieval evals, because you actually have the ground truth chunk. If you don't have the ground truth chunk, you can use LLM evals to try to approximate these metrics as well.
And I think
yeah,
I was really excited about like this like I saw this and was like, oh wow, we can automate everything. Like any views from the ground and the practice and how well it works.
Yeah, so there's a few practical considerations that you need to think about if you actually want to do this. Generally speaking, one, it'll cost you more money because you're using GPT-4 to generate a bunch of questions. 2 is that you kind of might want to think about like a filter pass and carefully think about the type of data that you want to generate questions over. Because otherwise, like you might run into a bunch of situations where you just have the LLM like generate a bunch of irrelevant questions. An example here is like, let's take an archive paper, right? And I just use like a Llama 2 paper as an example because we were doing a bunch of benchmarks there. Half of the Llama 2 PDF is just references. It's just like references to other papers. And so if you go to the latter half of the document and take in a chunk and try to generate questions from it, and it's on references, right? And references are just like citations of other papers. The questions are going to be like, hey, what did this other paper talk about? And then obviously you're not going to know because this is a reference to another paper. And the content's not in the Llama 2 paper. And so basically, like depending on the type of data, if the data is poor, you're not going to generate good questions. So you need to kind of carefully think about whether or not your questions can actually be answered by the context. And so that's something you're going to have to think about for basically anything synthetic.
Got it.
Yeah, the next piece here is basically like if you go to the next slide, it's very similar, but this is basically just like how do you generate query response pairs for end-to-end evals. To some extent, this is this can be an easier problem than just trying to benchmark retrieval evals. And the reason is that this allows you to play around with like a bunch of different parameters in your RAG system and not just the retrieval part. And the end goal is just to try to like improve like generated response performance, right? So the process is very similar. You take in a document, you parse and chunk it up. You get GPT-4 to generate a bunch of questions from each chunk. Now you have question context pairs. And then what you do is to generate the ground truth response, you take the question and the ground truth context and you put it through GPT-4 and get back a ground truth response. So now you have question response pairs, and that becomes your eval pair, right? Your input and your ground truth output. So then you can run the question against your RAG system, see if you actually get like a generated response that's approximately good, and you can evaluate it with LM-based evals.
Like it. This is definitely another interesting approach where to evaluate the system, but probably slightly, I kind of feel like a lot of the challenge in all this is like, and it's funny, I don't know if everyone gets it kind of leaning in, but like a lot of the times, like getting your data right is like your main problem. Like either creating synthetic data that you believe, or just using we use like queries from our users and questions on our docs and just save them off and then hand label them. Like getting your data set in a spot where you feel solid about the data, whether synthetically generated or not, is one of the hardest and biggest. It takes work. It's a grind to go do, and people don't realize like that there's probably not a pure automation for that approach, for that part of it.
Yep. Exactly.
Cool. Excited to okay, so we got the building blocks in place, and now here's where kind of the complexity kind of begins in terms of like evaluating the systems. And the point is that there's now queries, there's questions. In this example, in the one we have is just questions on a RISE doc. So it's questions we get from our customers relative to the documentation. And the thing we're going through is, in our case, we kind of hand save these off. In the example we just went through, Jerry was actually generating these queries automatically. So the first thing you're going to need to do is, do you have good questions and do you have answer pairs on your docs, or do you have just good questions? And the scripts we have definitely require the questions. They don't actually necessarily require the answers for evaluating the retrieval itself, but they do require good questions. So getting the questions out, and then so getting the questions in some way, shape, or form is the first challenge. What we then do, what the scripts kind of does, and examples that we have do here, is we generate evals for the chunks. And so you're turning what was traditionally a retrieval problem into being able to analyze it as a retrieval problem, where the evals were that building block here. So the ones and zeros on the right side were eval generated by that eval template you saw previously. So it becomes a retrieval problem. In one case, you've retrieved 3 chunks that are relevant. In the second case, it's maybe one chunk there. And once you have those numbers, you can start to do things like say, well, what's my precision at for example, for this? Or what is my MRR for these? So you can kind of get an idea of like how well that retrieval system's doing and start to plot and generate metrics for this. So the idea is just, you need the queries, you need your retrieval system set up, you need confidence in the relevance eval you're running. But once you have those components together, you can start to do some more traditional search and retrieval measurements. And we've tried to make this easy for you. We have a great script with Llama Index and Phoenix, which is Arise's open source software, that kind of runs through this, and we'll show you some of that automation there. The other thing you might care about is not just whether retrieval was good, but whether the RAG generated answer was good. And so there's another level of analysis that can be done or should be done to not just say whether the chunks retrieved were great, but did the full answer get answered correctly. And things that might affect that is, you can imagine, maybe chunk order in the window, maybe the most relevant chunk at the top of your context window might matter more than the bottom. So there's one thing about getting relevance and relevant data into your context window. And there's kind of another component here about just getting the answer right, which is what most people care about in the end. Yeah, anything to add on this one?
Yeah, I mean, I think exactly as you said, like the interesting thing about like the interaction between retrieval and synthesis is that like the ranked order with which you return results isn't necessarily the best order for like feeding to a language model. Like that part isn't completely clear. And so I think, as you said, like maybe the ranking within the retrieve set doesn't matter as much as just like being able to get back a bunch of chunks in the first place and making sure the chunks are like contiguous. I think we'll see that later on in the results too. But I think the other piece is like, yeah, like the loss in the middle problem means that like if the relevant context is in the middle of the window, right, and not at the ends, then it tends to be forgotten more by the language model. And so one strategy that I think we had in Llama Index is like, let's say you have like the most relevant context to least, so like 1, 2, 3, 4. You can like zigzag it and alternate it across like the beginning and ends, so that you basically like make sure that the front and the back have an equal distribution of like the top rank context. And so as you go into the zigzag, the least relevant is actually in the middle. These are all kind of like hacks, to be honest, but it's just like, yeah, like the point is just like the rank order doesn't necessarily lead to like good response synthesis results.
Yeah. Yeah. And I mean, we have some really good results, I think, from the benchmarking scripts here too, that tell some of those stories too. I think one of my takeaways, I actually don't want to give it away yet. We'll show it in the next results, but I do think there's a ton to be learned, both in what affects Q&A and what affects, and how, what is good retrieval. The good news is like the results we've seen is they're correlated. Like good retrieval drives like good precision at K, or good MRR drives good Q&A. And I can say for sure those two are correlated, but it doesn't mean they're exactly equal either. So the scripts we have allow you to point at your docs and sweep through different options. So you can there's a couple different retrieval approaches integrated in. We're kind of trying to add them all. You can set your different chunk sizes you want to integrate across. You can set your K, which is the retrieval size that you kind of saw in the previous one, and sweep through these and get results. And really, it's designed for the early stage, maybe as you're developing, giving you some gut checks of maybe what I should go do. So our goal is to like give you some idea of how to set up your system with some amount of rigor that we've kind of hoping this, but that our customers have wanted in the ecosystem. A little bit about this, it just kind of shows what sweeping through chunk size looks like. This is an example of a K equals 4 returned with a 500 chunk size to 1,000 chunk size, and just kind of an example of like what a sweep here. And you can sweep all these variables together, so do all combinations thereof on just pointing at your docs. You can sweep through Ks, so you can kind of get metrics on these values as you go through Ks. And what we found is I think the K, I think one of the big insights is also on K, which is how would you describe K? It's just like the context window size that you're dealing with. It basically retrieval chunks and plus context window.
Yeah. Isn't it just like the number of retrieved contexts?
Yeah, it is. And I think how it affects results would be like what you can fit, what you're trying to stuff into the context window.
Yeah. So I think that the maybe one bit is like if the K causes the total number of tokens to exceed the context window, then you need to enter some response to the strategy. So that might actually affect the result. So the moment it overflows a context window, it's not just a single prompt anymore. You're breaking it up into sub pieces.
Yeah, agree. And I think that there's some retrieval approaches here. So there's different kind of retrieval approaches that we've seen. I mean, the good news is like re-ranking actually does influence the MRR and precision at K metric. So the good news is re-ranking actually improves the retrieval results, which is what you'd expect. And so that's measurable. It's measurable. but the question is going to be like, does re-rank help you with Q&A and stuff like that? And I think we'll dive into the numbers and talk a little bit about maybe some trade-offs eventually. There was one question earlier, I think from the team from way back before we hop into the final things, which was, do we believe the GPT generated queries are representative of real queries? So it was back to your query generated section, because it seems like you want to be tolerant to various anomalies, language barriers, and lack of clarity. So I think you kind of hit that previously.
Yeah, probably not, but it's a proxy. So it kind of depends on your use case. The questions, like when they work, like it's not unrealistic. Like, it's not like they generate like garbage questions, but definitely like depending on your use case, like it might not be representative of the specific type of questions you want to ask. I think the main value prop of this, and some of this you could probably get by through like prompting and just giving it like few shot examples. That would probably help actually. If you have like few shot examples of like types of questions that you do want to ask. If you have like a bank of existing questions, you want to generate new questions, you could use that to help. But yeah, like I think in the end, it definitely depends on your use case. And these are all just proxies. And assuming like the costs come down for data set generation, then it's just very cheap and fast to do synthetic data set creation, and you might as well do it.
Yep. Agree. And I think I think a lot of this stuff is kind of a mix of both. Like you do some synthetic, do some like hand created, you're trying to create like variety and volume, and then maybe some data sets with very curated quality too. So like it's good. I don't think it's kind of a one size fits all either. It just helps you automate, and especially in your earlier stages too. I think if you don't have any data or questions from customers, like it can really help kickstart your initial results. So as you're thinking about like what you can do is you can point the data or docs. You can basically look at it generates directories of data and results. And my view and what I'm seeing is these results will vary I'm sure by your documentation. So don't assume like any insights that I've achieved on our docs necessarily, like some might be global, but I would actually assume you probably need to test and think about your docs first. Yeah, the first note here is that you do get like some some retrieval performance leaps as you go to higher chunk sizes from like the very, very small chunk sizes. You do get some leaps here from like this one's a chunk size 100, your base method of retrieval, to like say a re-rank. There is a small leap that you get in performance of these. A little bit of a leap as you go from your relevancy as your chunk sizes get bigger. Actually did hop up here a bit. So maybe you're more likely to get some of the text that's relevant for slightly larger chunk size. So you're seeing some small little bits here based upon the questions. I think different docs will actually have different increases. We will see as you go to really big chunk sizes that Q&A and stuff kind of drops off a bit. So there's some nice spots in the middle that you can help zero in onto. Normally we look at precision at K and MRR. Precision at K tends to be slightly less affected by actual order, where MRR should be slightly more affected by orders, but it's all somewhat relative. But precision at K or MRR are probably the two go-to that I'd be using to look at these. And then I do think the retrieval, the places where you have the better retrieval tend to have the better Q&A. And then there's latency, and I think the latency is a big one. Like if you're choosing a really complex approach, like some of these use, for example, Cohere re-ranking API in the middle of your calls, you might not want, and you're waiting for user responses, you might not want to do that. So there's a trade-off between your performance and kind of the latency components here. Anything to add there?
No, yeah, sounds pretty good.
Yeah, and then I think the final thing that people care about is just kind of a little bit of this one, which is like so these are chunk sizes of 100 on the left corner here, 500, 300 down here. So it's 100, 300, 500, 1,000. with different kind of Ks, and then a couple different like algorithms for retrieval associated with them. And as you go, lower in like the 100 chunk size, you're there is a kind of a worse Q&A performance versus some of these middle 300 and 500. The best performance is kind of middle range here. And then as you go up on your chunk sizes, you do get kind of worse Q&A. And the question on some of these is like, I think the question would be, at 10, are you overflowing massively your windows and trying to aggregate things together? Like some of these, I think that point you made previously might be happening under the scenes, but interesting enough, like at some point here, at 1,000, it's kind of worse performance in the 300 or 500. There's somewhere nice in between of the set, and again, probably document dependent, probably like questions dependent. This is our docs, our questions, but gives kind of an idea of like the different ways of sweeping these and understanding kind of how to set things up.
Why do you think the re-rank results get worse?
I don't I don't know. Like I do not know. That is worth digging. I mean, it's worth digging into. It's not what I would have expected. Part of what I thought though is interesting is you might want to like part of when I was looking at the data, I was like, wow, the fact that as I go up to 10, go from K4 to K10, it's almost consistently getting worse. Like maybe the thing to do is re-rank and then just cut off the bottom, like re-rank 10 and cut off the bottom 6. Like part of me looked at this and just said, maybe there's an approach that could make the whole, could make the whole thing better. Re-ranking definitely was improving the relevant metrics. For some reason, it just isn't moving the Q&A.
So you're re-ranking, but you're not truncating any context, right? You're just shifting the order of the retrieve context.
I think that's what's happening here.
I think that's what's yeah, that might be, it's probably just related to the previous point, because like in the end, like how does the order of the context matter in terms of like how the LLM synthesizes it? And if the re-ranking just shuffles the context around a bit, it might actually make the synthesis performance worse. I think you'd want to re-rank and then filter, actually, like retrieve like K equals 10 and then like set K equals 4. And then you probably get better results actually.
Agree. I mean, it's going to be, I think it would be a good test to go do from a retrieval perspective. Absolutely. In terms of,
it's a good lesson though, and sorry, and that like maybe this for like the audience is just like, if you're going to do re-ranking, like it's not really just about shuffling context for the LLM context window. It's like the whole point is you want to re-rank on a broader set and then filter it down to like a smaller set, so that smaller set is more relevant than if you just did naive top K.
Got it. And any other things like the other thing I was thinking here too was it would be really great to like the other one we didn't integrate here was, I think there's a parent-child kind of retrieval approach you have where like you maybe are using a smaller context for the retriever method and then a larger context for the generation. Yeah, do you want to describe that method? And I think what we'll try to do is we'll try to integrate that eventually into the script here too.
Yeah, I guess I don't know how much detail we need to go into right now, and the reason is like we have like over like a dozen different like advanced retrieval techniques in LlamaDocs. That's kind of just like you can go in and try it out yourself to see like how well it works. And so I think I actually like the focus here, which is just like, given just like the chunk sizes, which is a pretty important parameter, the top K value, and then also whether or not you re-rank. It's a pretty classic like search problem and how that affects like performance. There's like, yeah, so I think it just a flavor of like more advanced things you could do is just like right now you're kind of just retrieving document chunks as like a flat set of text. What you can do is you can like kind of model relationships more hierarchically. Like you can retrieve first by documents and then retrieve relevant items within each document. And then that's like basically one idea. You could retrieve stuff by like references, like embed like the metadata or the summary of the document instead of like the document itself. That's another powerful approach that seems to work pretty well. And then another idea is just like you could retrieve based on like sentences or small chunks, and then kind of expand the window around that sentence to return like a broader chunk. So we have a bunch of stuff in Index that you could definitely try out. I think in the end, for any of these approaches, like end-to-end evals, like question QA evals is quite important, right? Like you want to make sure that this actually works well over the type of data that you want to play around with.
Yeah. There's a question, maybe another question is if there was an automated process to trim off the worst chunks, could improve a targeted query over time within a session. So it's kind of a question, if there was an automated process to trim off the worst chunks, could improve a target query. I think that's exactly what we're getting out of the ranking one. You know, the question from Frank here is if there was an automated process to kind of trim off the worst chunks, like and by the way, do you support that today? Maybe we just didn't configure it in our test set here.
I think so. I think it's just like you do re-ranking and then you can filter by top K, like just order it by similarity.
Yeah.
Yeah. Yeah, I mean, I think that would like, yeah, I mean, I probably agree with Frank, like on a general level, like I think that would improve results. But yeah, it'd be definitely be interesting to try out.
Yeah, and I think the other question from the set here was how can we know how well the LLM can act as an evaluator for correct or incorrect answers? And I think that's I think this Bing Yang asked that, and it's a tough it's one of the tougher questions. We do have like test sets. We have like our QA our QA eval actually has some test sets that we test against that helps you kind of build some confidence. I think what I would say is build your own data set, use your own questions, spot check it, make sure you feel confident with it. Even feel free to kind of build a golden data set to make your confidence even stronger. We try to kind of come in with some pre-tested data sets and evals. But I think each person needs to kind of like run their own data and feel confident on it. Yeah, that's kind of the core of it. In the end, the Q&A evaluator takes the context. So like, what are the documents saying? What is the question and what is the answer? And your big question is, can GPT-4 reason about the question and answer and validity of it with just those contexts? So that's kind of the core idea. I think we found it does a pretty decent job. So GPT-4 does. You can see the GPT Turbo results right next to it in our docs, and it's not as good. And so what's the difference between the original method and original re-rank? So the original, do you want to define the original method, by the way, is just the traditional, query embedding retrieve versus re-rank. Do you want to describe a little of that? I think we hit on it a little more detail.
Maybe just for the audience, like what is a re-ranker? Like a re-ranker is something that takes in generally like the original question, and then like the set of like chunks. It could take it in as a group, I guess, or it could take it in independently, and then outputs like some sort of relevance score on how relevant that chunk is to the query. So it's usually a bit more computationally expensive than just pure like embedding dot product, embedding lookup. And it's called re-ranking because technically you already have a ranking from the embedding, the embedding similarity scores. And then you can re-rank it using some more computationally expensive process to then really try to figure out what context is most relevant to the question. So I think you guys used Cohere re-rank, if I'm not mistaken. Like Cohere has an API endpoint that's specifically just like, hey, give us some stuff and we'll re-rank it for you. You can also, there's re-ranking models. You could use your own from like the cross-encoding models from like sentence transformers. You could use an LLM to do re-ranking for you. There's a lot of different possibilities. So I think what you guys did, if I'm not mistaken, is you just took the original ranked set from embedding similarities and then ran it through Cohere re-rank and then basically got a new ranked set. And then, but like you didn't do any filtering, right? So you just took the original set and like stuffed it into the LLM context window.
Correct, exactly. And that's probably like, I mean, looking at the data, that seems like part of like the absolute next step of thing I would try is just to make sure we're cutting off the least interesting chunks. But and we're goal is also to set this up, be able to run it on a lot of docs, not just the kind of the example I have here on our docs. And we're already started running it on customer docs. And the question is like, is there any globally things you can say like does the increase in K decrease Q&A performance consistently, right? Like that, like that's one of the questions we're asking ourselves. Is like a bigger K always going to consistently drive lower Q&A, or is it totally docs dependent, questions dependent? Yeah, so I think those are the things that are kind of open questions, but kind of fascinating for any of you on the call here might be the person to answer that and cutting edge of the ecosystem. There's another question here on the golden data set. So could you expand on what you consider a golden data set for this task? I'll kind of come back to kind of this. In the golden data set for this task is really a good, it probably would be a good question answer pair. Like if I was going to really look at performance from an eval perspective, I probably would want both the query and the answer that were really solid on my data. So say you're talking about a chat on your docs. What are good questions that people might ask about your docs, and what are the right, what are some and this is kind of some answers, but you could also have some real answers. So you can actually judge the difference between the two. So like what you're generally going to want is some good query, good query data, possibly some good answer data to understand if your answers are correct or not. But the number one thing is probably, first get good questions across that. So golden data sets typically are going to be some data set we can judge the performance of the eval with. And so an example here is like, this eval is trying to say whether this question and answer are this question, this answer answers the question based upon the chunk data. Normally our golden data sets are trying to get precision and recall off that, so we trust it. So in our examples docs, we have those, and we have pre-labeled data and understand whether the answers are correct, and you have some precision and recalls. And then when you let it go in production, you're kind of you have some gut check that it's actually correct. Going back to this, so challenges on the ground. I think this was a thought I kind of had as I was going into this, is that so by the way, we got another one. Vibu, diverse golden data sets really help with regression testing too. It really helps highlighting queries with slight challenges in prompting and retrieval degrades performance. And I noticed cutting off re-ranking has a pretty big hit on some edge cases. So this is, Vibu's note, and I think he's been doing a lot of this. The golden data sets are pretty, like people like. I feel like a lot of teams, a lot of the really good teams are creating these like data, like once you're in production, you're finding examples that either break your system, and then you have a fix for, and then you're adding those queries, you're adding those kind of examples to the golden data sets as you're going. So a lot of it is like building examples that cause you pain, or like had you go fix something in the template or prompt or system. And those become good examples to test with in the future cases. I had this thought on this one, which was we have some customers with a lot of docs, and you can get like a lot of chunks. And if you think about the problem as like, okay, I'm trying to limit the number of chunks to something reasonable, but then I'm talking about millions of chunks of data. Like it becomes like a really interesting, tough problem. Like this problem formulated this way, it's kind of like a fundamental problem, I think, of AI memory and AI, using LLMs on your own data as you think about like the future of this ecosystem. And it's something like we're probably all going to be dealing with for honestly years. I don't see it getting fixed. And so the question's like, how do you manage how many chunks you look over and how well that retrieval is, and how do you get the data in? And I think we came to the conclusion that like some of the stuff that you're working on, Jerry, around like the metadata, the metadata actually, feel free if you want to talk about this, but helps split up the system in different ways based upon like some combination of semantic and metadata together.
Yeah, so I think let's see, I think basically like vector databases and like any sort of like search algorithm, like they're all starting to realize the same thing, which is like to really retrieve like the best candidate set of results, like you need not just like semantic search, but also some sort of like
Yep.
structured filter capabilities. And so basically this idea, like, yeah, if you have like, like 1 million, 10 million documents and you want to retrieve like some relevant set of context, like given the question, yeah, if you just do like top K embedding search, you might just get like random results, right? Like within this document set, like the precision is just not going to be high enough, so that you need to widen the top K quite a bit to get back like any sort of relevant context. So if you're able to filter for specific structured data beforehand, and these days like vector databases support like metadata filters where you can like filter for a specific set of data and then do semantic search within that data. That's pretty much something that like a lot of, well, one, vector databases are implementing, but two, does help improve performance. And so what you can do from like the LLM side is you can, given a user query, like if you have access to the metadata and the schema, like not just run semantic search, but also try to infer the metadata filters that you want to look for. At the end of the day, right, and this is like a hot take, but like, I'm pretty sure this will converge over time. Is like, you're like, there's a reason why SQL is a very powerful language and why people like writing SQL, because it's just a very expressive language for being able to filter for relevant pieces of information. That's like one big use case, like a select star with like a join and where clause and all these things. I think like as these interfaces evolve over time, you're gonna not just see like semantic search for chunks, but you're gonna somehow that's gonna join with some domain specific query language that can basically write SQL for you, right? So that you can like do some sort of structured querying for relevant context. We do support some of this stuff in Llama Index already, but obviously like the database interfaces will probably evolve over time. So we'll kind of like evolve with them.
So there is like a notebook that runs this, and you can point this at your own documentation. There's some parameters here where this is an example on the Rise docs with the Rise questions. You can point it at your own docs. We did launch Phoenix too as part of this, so it's a works really tightly with Llama Index, but you literally can see like one type of query, one retriever set, one retriever example. Here I've got, this looks like my K equals 6, for example, here. But I can see like, what does it look like under the hood for the same question versus maybe a different retriever approach here. And so there's a pretty awesome set of tools here for like understanding, in this case, you can see re-rankings in the middle of this, just what's going on under the hood. And we're tightly integrated with Llama Index here. So you can kind of get the best of both worlds, great retrieval tools and great troubleshooting tools together. So I want to highlight these notebooks are available for running these scripts on your own docs with some awesome tools for troubleshooting the templates used and what's going on under the hood for this stuff. Check it out. A little plug for Phoenix. So let's go to some questions in the set here. So is there a good resource for metadata creation and filtering implementation on data sets generally? Any thoughts on that? I feel like you have some automated tools for some of that, or do you find people just do it by hand? Like if I have e-commerce website, it's already broken up and I kind of know what it is.
Yeah, a lot of this is pretty use case specific, and you can use like traditional NLP models, like tagging, like NER, that type of stuff. You can use the LLM too to do metadata extraction. Actually, it's not a bad idea. One thing that like Llama Index supports is like you can just like given any piece of text, extract out like some sort of structured JSON from that text, and then you can basically then go ahead and then append the structured JSON as metadata to the text. So what types of metadata does this include? It could include like very simple numerics, like, oh, for a given PDF, what's the page number, right? You can add that as metadata. What's the file name? That's also a very popular thing. A lot of these, like, you don't actually need like some sort of automated extraction mechanism. You can just like do it heuristically or via code. But if you want to extract out more complex metadata, like given some unstructured text, let's tag it with like the topic or sentiment or like, some set of like questions that this thing can answer or a summary. Like that stuff you might need to use some language model to help you. And so there's like a spectrum. I think if you can do it manually, I would do it. But then if you can also try to add it, like use LLMs to extract some of the stuff.
Yeah, and there's one other question from Alex here, which is probably slightly off topic, he says, but any advice on how to improve more complicated retrieval techniques like routing queries to different types of documents, e.g. using Llama Index's router query engine? Better tools, descriptions, question mark, kind of treating the tool descriptions like prompts. Yeah, so I think it's, yeah, any thought? I mean, I think it's like all of the above, like benchmarking plus troubleshooting tools.
Yeah, basically. The router query engine isn't covered in this notebook, but like for the listeners, like the router query engine basically is a way to, given a query, like try to route the query to some underlying query engine that could be like vector top K search. It could be some other retriever. It could be anything you want, basically. So it's a very flexible abstraction. All it does is like take in a query and select what the choice is underneath. Yes, so all like, better tool descriptions, treating it like prompts, using a better model typically helps, but it'll just add latency. One thing that I haven't really gotten to yet, but that's something I really want to explore, maybe this week or next, is just like fine tuning a classifier. So like, can you just fine tune a model to be better at routing? In the end, a router is just like a classifier, right? And so like, given a query, can you actually just like fine tune on GPT-4 outputs, make it faster, cheaper? And like, that's something you could try out too. We don't have like inbuilt support for that, but that's something I want to try out.
Cool. Yeah, I think I mean, good questions. And just quick highlighting of like the stuff that's available here for teams if they want to use it. There is a parameter section, and there's a notebook here. So first off, there's a notebook here that gives you some descriptions of things, but there's also scripts that just run this too. And if you're running a long running thing, I would use the scripts directly. But the notebook gives you some easy approaches to doing this, and then there's some parameterization of this here. And you can set your chunk sizes, you can set your Ks, you can set like different things relative to those kind of different query engines, and then use those. And then as mentioned, there's a Phoenix integration where you can just kick off Phoenix relative to this notebook that runs next to it. So you can kind of see like whatever's going on in the notebook. You click a link, it's local to your data, it's open source, and you can troubleshoot the stuff right next to it. So check it out. Kind of goes hand in hand with this material here. More retrieval approaches coming, more more stuff coming, and there's some links if you want to kind of get at the either scripts or these kind of eval so the eval notebook that we have. So hopefully everyone got a good amount out of it. Let's just see if there's any other questions we didn't get to. No, I think we got to most of them here. So awesome. Great having everyone, and awesome, like everyone's interested in this and trying to improve. We're just trying to, thank you, Jerry, for kind of doing this with us and kind of diving in. And, I think we're all trying to like solve, we're all trying to get better metrics and understanding of what are these like complex systems and how to improve them, and what are the knobs and levers and what's the visibility we need. So appreciate, giving your insights and spending the time with us.
Thank you. This is great. Yeah. Thanks for the notebooks and the resource. And thanks for organizing this.